Good morning, respected teachers. Today we are going to discuss about the topic that we have prepared as a PPT presentation, that is probability distribution. So let's start. There are two types of distribution: frequency distribution and probability distribution. Frequency distribution is a listing of observed actual frequencies of all the outcomes of an experiment that actually can occur when experiment was done. Probability distribution is a listing of the probabilities of all the possible outcomes that could occur if the experiment was done. Probability distribution can be described as a diagram like probability tree, a table, a mathematical formula. There are two types of probability distribution: discrete PD and continuous PD. There are two types of discrete PD: binomial distribution and Poisson distribution. There are one type of continuous PD, normal distribution. Discrete distribution is a random variable, can take only limited number of values. Example, number of heads in two tosses. Continuous distribution is random variable, can take any value. Example, height of students in the class.
When a fair coin is tossed, we have some outcomes. So in the slide number 5, the tree diagram to that is shown here. In the next slide, which is attached probabilities, here we are shown about the independent and dependent events. Independent events are the ones in which the first spin has no effect on the second spin. But if the first spin has some effect on the second spin, it is known as dependent events. We move on to our next slide, which is how to calculate probabilities. Now there are various ways in which we can calculate probabilities, but there are some traditional methods. So one of them is shown here.
Discrete probability distribution example: tossing a coin 3 times, so the outcome is HHH, HTH, HHT, HTT, THH, THT, TTH and TTT. Let X represent number of head. If X is 1, so frequency is 1 and Px is equal to 1 by 8. If X is 2, so frequency is 3 and Px is 3 by 8. If X is 3, so frequency is 1 and Px is 1 by 8. That's all. Now we describe the binomial distribution. A binomial distribution can be thought of as simply the probability of a success or failure outcome in an experiment or survey that is represented multiple times. The binomial is a type of distribution that has two possible outcomes. There are certain phenomena in nature which can be identified as Bernoulli process, in which there is a fixed number of n trial come out. Each trial has only two possible outcomes, say success or failure, true or false, etc. Probability of occurrence of any outcomes remain same over success trials. Trials are statically independent. Binomial distribution is a discrete probability distribution which expresses the probability of one set of attractive success and failure. The binomial distribution is frequently used to model the number of success in a sample of size n drawn, which represent from a population of size n if the simply is coming out without replacement, and so the resulting distribution is hypergeometric distribution, not a binomial one. However, for n much larger than n, the binomial distribution remain a good approximately and widely used.
Four coins are tossed simultaneously. What is the probability of getting? First question, no heads. Second, no tail. Third, two heads. Next question. The probability of a bomb hitting a target is 1 by 5. Two bombs are enough to destroy a bridge. If 6 bombs are fired at the bridge, find the probability that the bridge is destroyed. Next question. If 8 ships out of 10 ships arrive safely, find the probability that at least one would arrive safely out of 5 ships selected at random. Next question. A pair of a dice is thrown 7 times. If getting a total of 7 is considered as a success, find the probability of getting first no success, second 6 success, and third at least 6 success. Another question: 8 to 10th of the palms were correctly filled. Find the probability of getting exactly 3 of 6 palms correctly filled.
So here are some formulas related to measure of central tendency and dispersion for the binomial distribution. Number 1, mean of BD, mu equals to NP. Second, standard deviation of BD, sigma is equal to root NPQ. The mean of BD is 20 and its AST is 4. We have to find NPQ. This is a numerical question. Number 4, the mean of BD is 20 and its AST is 7. Again you have to find NPQ. This is also a numerical question. Fittings of binomial distribution. 4 coins are tossed 160 times and the following results were obtained. If number of heads is 0, the frequency is 17. If number of heads is 1, the frequency is 52. If number of heads is 2, frequency is 54. Number of heads is 3, then the frequency is 31. And the number of heads is 4, the frequency is 6. And here we have also shown the data fit a binomial distribution under the assumption that the coins are unbased. Poisson distribution. When there is a large number of trials but a small probability of success, binomial calculation become impractical. If lambda is equal to mean number of occurrences of an event per unit interval of time per space, then probability that will occur exactly x time is given by p of x, which is equal to lambda to the power x into e to the power minus lambda by x factorial, where e is Napier constant and the value of e is 2.7182.
Let's talk about Poisson distribution. The Poisson distribution is the discrete probability distribution of the number of events occurring in a given time period, given the average number of times the event occurs over that time period. Occurrences are statically independent, and mean number of occurrences in a unit of time is proportional to size of unit. If 5 is 1 year, 10 in 2 years. The mean of Poisson distribution is lambda equal to NP, and it is always right skewed. Now let's talk about normal distribution. A normal distribution is also known as Gaussian distribution, is a type of continuous probability distribution for a real valued random variable. The general form of its probability density function is the parameter mean or expectation of the distribution, and it a standard deviation. It is symmetrical and unimodal. Since it is symmetrical, its mean, median and mode all are coincides, that is, all three are same. The tails are asymptotic to horizontal axis. This curve goes to infinity without touching horizontal axis. Its x-axis represents variable like height, weight, etc. and y-axis represents its probability density of function. Now let's define a normal distribution. Only two parameters are considered, mean and standard deviation. Same mean, different standard deviations. But same standard deviation, different means, different mean and different standard deviation.
So after a brief discussion of normal distribution, we find out some curve related to area under normal curve. As you can see the curve, how it looks like. and this is also a curve which is 68, 95, 99.7 rule, where 68 means 68% of data, 95.5% of data, and 99.9% of data.
Area under the curve. The mean plus minus standard deviation curve approx 68% of the area under the curve. The mean plus minus 2 standard deviation curve approx 95.5% of the area under the curve. The mean plus minus 3 standard deviation curves 99.7% of the area under the curve.
As we have discussed previously the topics like area under the normal curve and area under the curve. Now let's discuss what is normal PD means probability distribution. In standard normal PD, mean will be equal to 0 and standard deviation will be equal to 1. Now what is Z? The formula for Z will be Z equals to x minus mu upon sigma, where Z is called as number of standard deviation from x to mean, also called as Z score, and x is equal to value of RV. Now after the brief discussion of this PPT and slides, let's take some problems. First question. Mean height of Gurkhas is 147 cm with standard deviation of 3 cm. What is the probability of number 1 height being greater than 152 cm, number 2 height between 140 and 150 cm? Second question. Mean demand of a oil is 1000 liters per month with SD of 150 liters. If 1200 liters are stocked, what is the satisfaction level? Number 2, for an assurance of 150 95%, but stock must be kept. Now third question. Nancy keeps bank balance on an average of rupees 5000 with standard deviation of rupees 1000. What is the probability that her amount will have balance of number 1 greater than rupees 7000, number 2 between rupees 5000 to 6000? Now at the last, this PPT is made by the students of IT from Department of Engineering Science and Humanities of roll number between 2 to 16. I hope you enjoyed the slides. Thank you. Stay safe. Stay home. Goodbye.